Hello everybody. Today we are going to talk a little bit about an ideal operational amplifier. Okay, so basically in an operational amplifier we have these 5 terminals. Okay, this terminal, this one here, is connected to the positive voltage source in order to bias the operational amplifier. Okay, and this terminal is the negative voltage source terminal, which is connected to a negative voltage source. Okay, these voltages are symmetrical in most of the cases, and it could be, you could find single supply operational amplifiers. I mean, you could find operational amplifiers biased between VCC and ground. Okay, but generally we are going to use it like this. Okay, so you have to connect the amplifier to voltage sources in order to bias it, because the operational amplifier is composed of transistors internally and they have to be biased for it to operate. Okay, then we can see this output terminal, which I'm going to call B0, and we have 2 input terminals: an inverting terminal, which we are going to name B minus, and a non-inverting terminal, which we are going to name B plus. So the operational amplifier is a voltage amplifier. This means that the voltage is going to be again a factor that we call gain, which is the gain of the amplifier. We are going to name it like this. Okay, multiplied by a differential input. In this case, this input equals B plus minus B minus. Okay, the input impedance of the amplifier tends to infinite. Okay, the output impedance, which is the impedance since from the output port to ground, equals 0. Okay, and the currents to the ports of the terminals, which we are going to name I minus and I plus, equals 0 in an ideal amplifier, as we are saying. Okay, so another feature of the operational amplifier is that its gain AD tends to infinite. So B0, if we rewrite it, B0 equals the difference gain multiplied by B minus B plus, sorry, minus B minus, which we name it before as BD. So this amplifier is not suitable to use it as an open loop amplifier, because even though this is very slow, due to the high gain of the amplifier, this output will tend to go to infinite or minus infinite. So it is impossible to use it as an amplifier like this. We will have to use it with feedback topologies, as we can see in another chapters of this channel. Okay, so there are limits. You cannot get this value at the output. The maximum output you can get at the the maximum value you can get at the output, the maximum positive value is plus VCC, which is the positive bias source, and the lowest value that we can have at the output of the amplifier is minus VCC. Okay, so if B plus minus B minus is greater than 0, B out will be equal to VCC. And when B plus minus B minus is lower than 0, B0 will be equal to minus VCC. This means that if we use the amplifier like this, we can use it as a comparator. As you can see, if the positive terminal voltage is higher than the negative voltage, we have VCC at the output, and if B plus is lower than B minus, we will have this value at the output. This will be suitable for comparator purposes. Okay, so the transfer function of this amplifier, B0 against BD, will be like this. So we can see this graphic, B0 against BD, which BD, as we said before, is B plus minus B minus. When this value is very low but positive, we are going to have a positive voltage at the output of the amplifier. Okay, and the slope of this straight line equals the gain of the amplifier. But the maximum value, as we said before, the maximum value that we can have at the output of the amplifier is the positive voltage which is connected to the amplifier to bias it. Okay, the same way, if BD is negative, we are going to get an output which is AD times BD. So when it becomes lower and lower, more negative I mean, this output is going to be lower and lower, more negative, to the point that the maximum or the minimum value we can have at the output of the amplifier is the negative voltage supply. In the case of the previous example, which was biased with plus VCC and minus VCC, this minimum value will be VCC. In the case that the amplifier is biased with a positive voltage and ground, we will have something like this. For positive values, we will have this response, and for negative value, the minimum value of the amplifier output will be 0, which is the lowest voltage supply voltage of the amplifier. Okay, so the characteristic of the ideal amplifier: a very high gain in the case of ideal amplifier tending to infinite input impedance, which means that the currents of the input ports equals 0. Okay, the output impedance equals 0, and the gain AD doesn't depend on the frequency. The frequency response of the gain of the amplifier is flat. It doesn't depend on the frequency. Okay, so very high gain. It is not suitable to use as an amplifier. We usually use this type of amplifiers with open loop for comparator purposes, okay? And if we want to use the amplifier, the operational amplifier, as an amplifier, we should use negative feedback topologies like inverter, non-inverter, other, and so on, okay? So if you like this video, please thumbs up and subscribe. It will help me a lot.